Hello learners. In this video, we are going to see about the principle of alternator. Alternator is nothing but an AC generator which takes the mechanical rotation as the input and provides the electrical energy as output. As shown here, it has several main parts for its construction: rotor, then housing, slip ring, voltage regulator, rectifier, hardware, stator and bearing. So basically, there is two types of there are two types of alternator construction is available. One is stationary flux based construction, and another one is rotating flux based construction. Rotating flux means magnetic poles are kept in the rotor side of the alternator. Stationary magnetic flux means magnetic poles are mounted in the stator part, which is not movable. So in both of these methods, the alternator can work. So let us see the part, each parts one by one. So this housing is used to protect the entire machine and gives the mechanical support for the entire machine. So bearing is used to support the center shaft of the rotor part. The voltage regulator is used to make the voltage of the alternate voltage of the alternator, that produced voltage should be maintained constant, because sometimes the speed may be somewhat varied in the rotation side. So when the speed changes, your output voltage of the alternator will also get changed. To avoid that, to make the voltage constant from the alternator, we are using this voltage regulator. Rectifier is used to convert that AC voltage into DC voltage, because in automotive vehicles, most of the loads are consuming DC supply only. So this AC voltage is converted into DC. Also, the main purpose of the alternator is to charge the battery. So for battery charging, we need DC supply. So to convert the AC output to DC, we are using the rectifier. So this is the motor hardware part. So this slip ring is nothing but uh, uh, three separate. If it is single phase alternator, there will be two slip rings. The slip rings are nothing but which enables the communication between the external source to the internal part of the machine, that is winding of the machine. So this is about the construction of the alternator. We can see the disassembled part of the alternator here. So pulley, which is connected to the front end bracket, and this is the shaft, this is the rotor windings, this is the stator side, inside which the rotor is placed with the minimum air gap of 1 mm 2 mm, like that. Okay, so usually this stator and rotor will not get physically contacted. Then this is rear bracket, this is front bracket, and this is rear bracket, and brush holders. We have seen about slip rings in previous slide. For single phase alternator, two slip rings are there. To get communication between the internal parts of the winding of the machine with the external circuitry, we need we need brushes, carbon brushes, to uh, connected with that slip ring. For that, carbon brushes to be placed within this holder, brush holder only. So rectifier part is here. Okay, so when the engine cranks, the alternator is fully uh, connected to the engine via the belt, so that it is also rotated. So inside the alternator, we have a rotor, in which here the alternator is made with rotor side magnetic flux. That's why here mentioned as a rotor with electric magnet. So when it rotates within the set of coils, as per electromagnetic induction principle, and EMF, that is electromotive force, that voltage will be induced. Once we provide a closed circuitry to the output of the alternator, it produces the current flow through the alternator. This is called alternating current. So rectification is mainly used to provide battery charging and to supply other kind of loads as they needs DC supply. The voltage regulator ensures the output voltage to be remains constant value irrespective of the speed of the engine. Okay, so the power delivery means the regulated DC power which is used to charge battery and also the various car appliances. So this is all about the alternator and its need to the automotive applications. We will see the next step in next video. Thank you.